Records kept by a large accountancy firm indicate that the mean time taken by its staff to prepare a personal income tax return for a customer is 145 minutes with a standard deviation of 32 minutes. A random sample of 74 times is taken from the records. State the approximate distribution for x bar, the sample mean time. So x bar would be approximately normal with a mean of 145 and a variance of 32 squared divided by 74. 74 is the number in the sample. And that means the standard deviation is 3.72 if we calculate it, 32 over root 74. Determine the probability that the sample mean time is within 90 seconds of 144 minutes. So that is 1.5 minutes up and down from 144. So we're after probability of 142.5 less than or equal to x bar, less than or equal to 145.5, and that is just a normal CDF, and if you calculate it, it's 0.3027. If there is a 66.7% chance that the sample mean time will fall below A minutes of the population mean, determine the value of A. So, what we have there is 145 take away A up to 145 plus A. And we know that probability is going to be 0.667. So we can do this with an inverse normal CDF as shown over here. We want a center setting, probability 0.667, and put in our standard deviation and mean. And we get 141.4 essentially. So that is 141.4. And the A, therefore, is going to be the difference. So what we're going to do is the 145 take away the 141.4. And so that gives us 18 over 5, or if I was in decimal mode, that would give me 3.6. A second random sample of n times is to be taken from the records. Determine the least value of n to ensure there is no more than a 2% chance of the sample mean time exceeding 150 minutes. So, let's draw the situation. So if we have our normal like this, there's 145. That would be 150, and we want this to be 2%. If we just go symmetric at the other end, that would be 140, and we would have 2%, meaning that we have 96% in the middle. So we can find the Z96 time, and we can do that just with an E activity and the Z score for CI. So if we make that one 0.96 and we solve for Z, you can see we get this 2.0537. We have the sigma is 32, and here we're making E equal to 5. That's the width there of that gap. And then we can actually do the sample n for CI just here. So the formula there is NZ sigma over E squared. Stick in all the numbers that we want to know over there, and you'll get that that is 172.76. And so we always round up, n equals 173.